Great. So welcome to this session where we're going to be hacking one of the products that I've been working on. So I'll give you inside knowledge about where to look and where to go for. And I think what I want to do is I want to walk you through how I think when I do a security assessment, but also the interesting balances that you have to strike when you're developing a product, right? And by the way, this is a beta product. We haven't launched it officially. So there's still a number of vulnerabilities I'm going to show you that we're going to fix it on the final release, right? But you get the picture of it. So first of all, just welcome to this training session. We expect you to participate, to challenge, to be involved. Everything we do is open. Everything is open source. Everything is released on YouTube. So if you don't want to participate in YouTube and just use NA or don't turn on the video. And again, we expect everything to be highly respectful of everybody and everybody to collaborate very professionally. And finally, share your views, join the Slack. I think most of you have started to recognize the names already in Slack. And then the hashtag is OSS 2020. And finally, you're here to learn, right? And we're here to share as much as we can. So what we're going to do is you should all have access to this website here that that you should be able to log out and log in with OSS 2020 for this site, and that should kind of look like this. So that's the UI that we are going to be taking a look at on this application. So probably what you want to do is go here, add a user for you, right? Put whatever password you want. And yes, there is a weak password on this thing, so which is one of the vulnerabilities. And also I want to start, while we're doing this, start raising the question of, vulnerabilities you find and other things. So let me just log out, log in as me. And if you want some files, you can go to this site here. So I'll actually go here, sample files. If you want some files to play with, again, I'll put this on a Zoom chat. You can use, oh, you're seeing a different browser. You're right. Oops. Let me share that. Thanks. New share. All right. Can you share? Not that one. Can you see this? Can you see the demo files now? Or is that? Am I sharing the correct one? Yeah.
Yeah.
Cool. And you can also see the forensic workbench, right? And the demo files.
Yes.
Cool. All right. Sorry about that. So what you got here is, so yes, if you want some demo files, so this is a good example of the sort of the power of the engine that we have behind here is also a good demo. So let me download these two files. So this is the works of Shakespeare, and this is the JavaScript embedded. So I'm going to take these two files. You go to upload, you kind of log in as you, and you basically you can upload the files there, and then so there's the PDF, and then you're also going to drag and drop the complete works of Shakespeare. So this file here, which is called a polyglot file. So the first one has JavaScript, as I will show in a second, and the second one is called a polyglot file. And what it is a file that actually has what's it called? Has other things on it, right? So this file here has, as the name says, the complete works of Shakespeare. So let me actually show that in action, because is actually really cool to see it in action. So let me open this up here. So actually, if I go like this, you guys should now see my desktop. All right, so can you see? Cool. Can you guys?
We're still saying at the GlassWall browser.
Cool. All right, so can you guys see my desktop now? So
no, File Explorer.
Yeah, File Explorer. Can you see it?
Yeah.
Cool. Right. So here's the file I downloaded, that complete works of Shakespeare. So let's just go in there. Let me actually rename it. Rename, test file, right? And so you can see that if you open this file, it's an image, right? See, nice image right here. But if I look at that file from the kind of so where is it? Test file, right? So if I look at that file from here, see that complete works. If I unzip that file, and what happens is all these other files were inside that file. In fact, you can see that the file is 2 megabytes, right? And if I actually also extract one of these guys, what you'll see is that there's this document that contains one of the works of Shakespeare, right? It's pretty cool, right? So, so that is called a polyglot file, which is basically a file that has other stuff on it. So this file is both a JPEG and a zip file, and you can have all sorts of variations of these files. And there's like even ones that are JPEGs and PHP files and all sorts of stuff. So there's actually some cool exploits that I exploited this stuff here, right? So clearly, we want this to be an image. We don't want this to be an image plus a bunch of other stuff. And actually, if I show you the JavaScript that executes JavaScript PDF, if you look at this file in Acrobat, you see that there's some JavaScript in here that we kind of don't want, right? So this is basically, we want the file to look like this, but we don't want this JavaScript to be there, right? So what the kind of GlassWall engine does is it takes those files and kind of cleans them up, right? And identify things. So you can see on that one, the engine identified that there's JavaScript on it, right? And then you can see on the results, I get the 2 files. So now if I download those 2 files, the clean files, what you now will see is that, for example, the new one, which is got here. So it looks the same, but it doesn't have the same size, or shouldn't have the same size as the other one, right? Because it should be cleaned, that one there. Although I'll need to double check that, because I expect that guy to be, oh yeah, there you go, sorry. Where's the date added? So, so this one should not have the JavaScript, correct. So that one doesn't have the JavaScript in there. And let me just double check one thing here. This is the other version of the engine. Let me just do the same thing here, right? To make sure that I'm actually not, everything's working smoothly. And so that's kind of the principle, right? So you upload files, you get to see that you removed a whole pile of stuff from the end of the file. So if you download the protected file, in this case, you get the, a much smaller version of it. So there you go, see, 2K. See that file there? That has 2K. So that's the original, that has 2K, right? So, it's a good example of the engine working in action. So what we want to do is we want to take a look at what happens behind the scenes here and how everything works and the whole flow. And if you have more files locally, you can just come in here and upload a bunch of files. So here are all the kind of examples of the file formats that the engine supports, from PowerPoint and DLLs and MP3s and WAV files, and also document files and embedded files and macro files. So you can upload a batch of files in here, and then it works. So while it does that, I should already be able to show you the behind the scenes. Cool. So this is what's happening behind the scenes. So if you start to look at the thread model of this and of this, what's happening is that behind the scenes, there is a series of Docker images that are running. So you can actually see the Docker image that you're just popping up there is the image that is actually processing each file. So if you process a large file, you see it running from here. But in normal periods, you'll see 3 Docker images running, one for the API, one for the client, one for Postgres, right? So that's fundamentally the 3 things we have. We have a Postgres database, we have an API and we have a client. The API is Node.js, the client is React. And then for every transformation that you have here, the file actually gets processed by Docker, and then the Docker instance gets destroyed. And the difference actually between this and the file drop that you see here, this is actually running serverless. So this is actually running yesterday we looked at that. So this is running at a different kind of workflow where we actually process the file and then, on the server, a Lambda function, and then send the file back. Cool. So now you get to see the tags, so you get to see the information that got there, and then you get to see the files that got processed here. And there you get to see the status and the analysis and what we actually did to the files, including you can download a bunch of stuff. Cool. Any questions so far? So first of all, you guys should have access to this. So for the ones who joined in, it might be worthwhile maybe just repasting the thing. So you should be able to log into this IP address. I'll just paste it again on the Slack channel, and then the password is OSS, and so username is OSS, password is OSS 2020. So you guys should be able to log in, and I would say log in and create a user account on this. So yesterday, not to go through some of the stuff we found yesterday. So yesterday we found already highlight a couple of problems with this. The first one, as you probably noticed, if you go to the list of users, there's users with very short names. And if you go here and create a user called, like that, you'll see that I'm able to create any user with a very weak password, right? Which is kind of not good. And I would actually argue here that the worst thing is that we don't support 2FA, which I would argue that these days is a fundamental requirement. Because actually, here's the question, right? Let's start with this question, right? At the moment, this application allows you to put a weak password on it, right? But it doesn't allow 2FA to be set. Which one is worse from a security point of view? So go on, what's your views, right? From a security point of view, which one is worse? No password, no 2FA.
So not really an answer, but it depends on your methodology you're using to score the vulnerability and how that falls into your risk management.
Well, I agree.
It's kind of,
but go on, so analyze it, right? So if you, from your point of view, which one would you claim to be a high?
I mean, if you don't have a password, but you have 2FA, I mean, you're going to have some way of authenticating.
No, so I'm saying weak password, right? So weak password, like the password here is AAA, username is AAA, right? So
I would say it's a weak password is the top, and 2FA comes second.
Yeah, agreed.
So weak password first and 2FA second?
Correct.
2FA with weak password is acceptable.
Well, yeah, so that's my question, right? And I agree with, I think it's Elvis. Is that you?
yeah.
So here's the thing, right? If you have 2FA, does it matter if you have a weak password?
If you have 2FA, it doesn't.
I mean, it's always going to matter if you have a weak password. It just depends on.
So being the old school, I would always say that I begin with the passwords have to be very much strong in nature, and 2FA or the authentication is something which is secondary in nature. So basic discipline of cybersecurity, you have to have a strong password.
But why?
Not sorry. With 2FA, it effectively you add by forcing 2FA, you effectively add a temporal strong password, effectively mitigating the weak or the weaker singular password.
But if someone's password is password, and I can gain access to their email,
You won't.
You know, it's not gonna.
You won't if you have 2FA, even if it's a weak password, right?
No, I'm saying if you can gain access to their other form of authentication, that's all you have to
Wow.
have.
But the
So
Basically.
that's
question
hard.
the question is, you know, if you have a weak password, right? Does it matter if you have 2FA or a multi-factor authentication on top of it?
It's certainly it's a mitigating factor that reduces the risk. No doubt about that.
Yeah. And
But,
I think,
but it does matter.
I don't really care if the password is weak and you have 2FA. I'm not saying it is acceptable, but I mean, it is. Imagine a phishing attack. Someone clicked on a link, they typed their password. Even if it's a weak password, not a weak password, it does not matter. In this case, the password is compromised, but you have 2FA. Voila, you know,
So
covered yourself.
weak passwords less of a problem for phishing. You know, phishing you can pick up for a one time. If you successfully phish the user, you can get their password, however strong it is. You can also get their token for one use. So really,
Well,
when
depends
you're
how
looking at weak
sophisticated your
passwords,
phishing is, right?
yeah, well, you can get it for one use. You can if you phish them, you have a temporal login for 60 seconds or so. So that's definitely a thing.
Well, wait, hold on. You have to take a step, right? Like, come on, you can phish me, right? To put my password, right, into a system, but you won't trick me to put my my number, right? Because, you know, I have to confirm it, right? And you have to send it to me. You have to send that number to my mobile, right? So now
Well, it depends how you're doing TFA. If you have a code that's sent over SMS, yeah. But if it's something like Google Authenticator using TOTP or HOTP behind it, then you're just asking the user to input the code. It's not generated by the system.
no, but but this is where we have to be realistic on the type of attacker that you've got, right? So in that case, like, I think most 2FAs today is either SMS or even application based, right? Where you get a pop-up, you know, on your phone and says, "Was this you?" Right? Which is, again,
Well,
not easy to you can't easily replicate that. So how does the attacker find my 2FA or simulate my 2FA environment?
So the 2FA I was thinking about specifically was Google Authenticator, which is where your phone or your token generates a code that changes every 60 seconds. So from a phishing perspective, it's not system initiated, it's client initiated. So agree, you've got two different, if you backpedal, if you look at if we take it right back to the threat, it's like, okay, I have phishing. Does phishing work with, what's the phishing threat with my 2FA solution? And the answer is actually, it depends on the details of your 2FA system that you're running. You know, is it SMS based push, or is it client initiated? When I say client, I mean user initiated codes. It has different.
Okay, fair enough, right? So maybe I'll caveat. If you have a reasonably well implemented 2FA solution, right?
But also,
Right.
sorry, but also it's, yes, you do get 60 seconds of 2FA, but it's never 60 seconds when you open that Authenticator app. It's always much less. And by the time you type it in and by the time you click, this already kind of expires. So I don't think the attacker has much time to really act on it.
And it's, if your phishing is automated. So this is, again, we're getting into levels of, I'm assuming that the phishing website takes the credentials, takes the 2FA code that's been generated, and instantly uses them to log into the target site in the background, and then can hold a session open for a period of time.
If you drop a keylogger on, then when they put in the multi-factor authentication, if it's, you know, that type, then I mean you can essentially record every bit of what they're doing and
yes. Okay, but let's take a step back, right? I'm not talking about you phishing a user, right? Because if you phish a user, or maybe just to clarify, right, you can have the hardest password in the planet, right? So if you're looking at a scenario where you're phishing the user and you're breaking the 2FA, which by the way, I've seen and I've been experienced it, and if you're facing attackers at that level, just maybe just to go on that tangent, right? If you have an attacker that is able to be sophisticated enough to be hitting you and be, for example, calling you straight away saying, by the way, we just send you a code. Can you register now? And is able to actually break both your 2FA workflows. You actually have to assume that the attacker will be able to get anything that the user gets, and your defense model is completely different. Your defense model then is based on detecting the attacker behavior, not preventing that occur.
Well, all you'd have to do is have the keylogger watch for that activity, and then as it picks up that kind of activity,
absolutely. If you have a keylogger on the page, in fact, if you have XSS on a page, right, you can bypass a lot of these things, right? Depends on, well, not the 2FA on the phone, right? But my question here was different. My question was, if you have 2FA, doesn't matter if you have a weak password, because the weak password is only a problem when the attacker can log in without you knowing. Correct?
If you go back to what are the threats that you're concerned about. So when we went down the phishing rabbit hole, weak passwords, 2FA, phishing, we'll put that one to one side. Brute forcing as a threat against weak passwords is completely mitigated by 2FA.
Yeah. So there's the password matter. But and you see the point here, right? And this is really interesting, right? Because I have to say that, I always, I think, had these instincts, but I think now that I'm also responsible for development, right? I have to say that it's very important when we ask a developer team to do something in security to make sure they focus on the right things. So I'll give you an example, right? Although we will fix this, because I think it's actually a good practice. So I'm not defending that you have weak passwords. I'm just saying that you have to have a level of rationality. But to go to a dev team and say, spend your credits fixing the weak password versus spending your security credits putting 2FA would, in my book, be the wrong decision. Because teams have a limited budget, have a limited amount of time that they can spend on security fixes. So it's very important that we, from a security professional point of view, we provide recommendations that add the most value for money from a security point of view.
So, Dinis, may I jump in?
Yeah.
Yeah, it's Vinod.
Hey,
yeah,
Vinod.
So I agree with your point. So that's why developers shouldn't spend on developing insecure authentication and authorization, right? So they should rather use a federated service, and that can have a phishing resistant authentication like WebAuthn or FIDO2, whatever it is.
Oh yeah, like spot on. Even better, implement OAuth on this thing.
Yeah.
Right?
Yes.
Securely.
Yeah.
And you
Dinis,
don't be like Apple. Yeah.
Sorry, Dinis, I only gave that phishing example just to say, in such a scenario, it does not matter if the password was weak or strong.
Yeah.
So,
but I think, Vinod, you got a great point, right? In fact, the biggest risk here is that we don't support OAuth, right?
Yeah.
In fact, the biggest risk here is why the hell is this application having, its own user management, where actually, if you go to OAuth or implement a solution based like that, you actually can get a lot of security by basically piggybacking on top of that, right?
Yeah, you're delegating the security or the authentication to a central service, which should securely authenticate it. Yeah. So the relying parties shouldn't worry too much about the authentication. They only worry about securely integrating with the identity provider.
I agree with you. So let me show you a vulnerability that when we look a bit later is going to be even more problematic, right? So can you see here that I have a user A, right? So and then if I open up here, you get, I can log in as, so user A and A, right? You can see I can log in. There's my user. Actually, let me show you something. So I'm going to just upload a couple of files here to this user, right? So that's just files there, and the files are going to be processed. Oh, wait, What happened there? Cool. And then what I'm going to do is I'm going to delete the user, right? And you'll see that once the user is deleted, I can log back in, and then I'm going to recreate the same user, right? There. So you can see the user has some files, the user has some stuff. I go to the home page. Here we go. You know, there's a bunch of files. In fact, you probably should see the problem already, almost. But okay. So I'm going to go here. I'm going to delete the user, right? Actually, no, not that. Delete the user. User, yes, user's deleted. But actually, if I'm not wrong, cool, all right? So that was good, right? So there's one thing here that I wanted to stress out is that before we look at the source code, right? Before you look at the actual application, and you need the source code when you're doing security reviews, because the point here is not for you to show the client, or if you're doing a pen test, right, how good you are. It's not a race against time. It's for you to validate their security understandings and for you to augment their security, validate the security understanding and find blind spots in those understandings, right? So I always think when I'm doing a review like a detective. So I'm looking for things that are good and I'm looking for things that are bad, so that when I go to the code, I have a series of mental models that I can use to follow it up, right? So a good example was just now, hey, the user got deleted, I immediately got locked out. That's good, right? From a security point of view, that's one of the things you want to do. There's a lot of security systems that the only time that your security credentials and your session is validated is on account creation. So that means that even if you delete the account, it's only, or account, login. So even if you delete the account, until you log in and log out, the user can still use the system, which might not be what you want, right? So I can here, I'm trying to log in, you see it doesn't exist, right? If I now come out here and create another user, right? Same name, same password, right? And now you can see I'm now logged in, and can you see what happened there, right? I still have access to the previous files. So can you see that this is a problem?
A huge problem.
So what's the problems here, right? So start listing the vulnerabilities.
Data retention is one of them.
And Petra, you're taking notes, right? Because we're going to have to fix this stuff.
Yeah, taking notes.
Luckily, it's video recorded.
Yeah.
You can run through.
So data retention is one, right? So immediately you ask the questions. And this is actually where GDPR is very important, right? Because GDPR, if you go back to it, one of the things GDPR says, right, is that you have to delete the data, right? Within a period.
Data minimization and retention.
Correct. Right. So if the user tells you delete my data, right? The data should be deleted. So that's one problem here, right? What's the other problem that you can see here?
So basically, you're not verifying the customer identity, and it can even lead to account takeover. Like, I don't know how you can bind that account without verifying some attributes, right?
Yeah. So for example, so you're basically saying that now I have access to data. User right now has access to data that you might not supposed to, right?
Yeah. So ideally, you should be doing some like attribute-based verification, like email verification or something to confirm that identity belongs to that account or something. I'm not recommending email is the best way, but at least as a minimum, something to enforce that no one else can take over that account, right?
Yeah.
Just because knowing an email ID or knowing a name or ID, they shouldn't be able to take over an account.
Yeah, but that would be if I use the email as the username, right? So there's a lot of, like GitHub, for example, doesn't use my email. I have a GitHub username, and yes, I put my email address. So this will be equivalent of I go to GitHub, I delete my user, I says, hey, delete my user, and then somebody else comes and creates a user with my name, and they have access to all my data.
Yeah, but GitHub shouldn't give that data without verifying you have access to that email
No,
or
but
something. I mean, yeah.
But in that case, it doesn't matter, right? I can use, you can use your email address with my name, right? So if the username is, so the vulnerability here is that the username is the same across multiple users.
Or so vulnerability, you are not depending on some kind of attribute that you can verify the user who is, I mean, claiming that account. So you have an existing account, right? So you are binding that existing account with a new account registration. That shouldn't happen without verifying some attributes that that account belongs to that user, right? Is that clear? Sorry, I was trying to. Yeah. It's something recently happened with the Apple's issue, right? Apple sign in with Apple. They didn't verify if the email ID belongs to whoever sending the email ID to their IDP server. They just give the ID token back. So, yeah.
Yeah, and look, and this is a variation of this kind of stuff, right? So have you seen the NPM had massive problems with, you know, somebody deleting, right, a particular NPM package that is used by, you know, tens of people, and then somebody uploads the same package with the same name, right?
Yeah, it's an issue with the package management. I think Golang similarly, I think they are preventing with this go and they check some database and they won't allow to do that.
Correct. So any other comments? So the thing that I would actually, in the back of my head, I would immediately make a note, which would worry me a lot, is the fact that the username is being used as an identifier in the backend, right? And then, so this is the main thing that you want to pay attention to. And this is where we can actually start to look at the traffic that flies back and forward between the systems. So if you look at the traffic here, right, and you look at me, you know, accessing the stuff and looking at the data and, you know, maybe seeing a file, view report, right? So actually, sorry, let me preserve cache so you get to see it. So I go here, I upload the file, I look at it, I go, oh, let me grab the file, let me view report. So if you look at these URLs that you have here, can you spot something interesting in them?
The A.
Yeah, and maybe if you want to see the difference, right? You get to see on this one, you know, here's my, oh, that's the thing, my results. I go there, view report, right? View analysis. All right, can you guys see the difference on this one? So that's with a different user.
Yeah, you have Dinis at the end of the URL.
So this is a very good example, right? Of I kind of call this horizontal, you know, vulnerabilities, right? And what it is let me just actually do this. Let me just do a drawing here because I think this is a really important diagram, right? Kind of problem that happens a lot, and I kind of want to make sure that you guys get your head around this, right? So all right, cool. So can you see my screen? And by the way, I found this really cool. Online visual paradigm is actually really cool, and it's a nice way to draw things online, right? So if you look at multiple types of users, right? So I have three types, let's say, you know, three types of users, which is you got anonymous users. So this is basically non-logged in users, right? Logged in users, whatever, so logged in users. This is, let's say, your normal users, and then this is your admins, right? So there's kind of two types of main kind of attack paths, right? One is that way. Come on, give me an arrow. Or give me an arrow. Okay, one is from there to there, right? Where what you're trying to do is basically exploit the. Okay, cool. So one exploit is from there to there, right? So you as a user are trying to jump from one type of account to another. So you want from anonymous, you want to see normal user data, or from normal user data, you want to see an admin data, right? Now, this is it's very common, and this is one of the reasons why you want to make sure that you map the entire attack surface, because you want to really test. And this is from a testing point of view. One of the tests that I want to see is a test that basically takes every single URL, every single request that is valid by an admin, and I want to run it as a non-logged in user. And the same thing with normal users, and that delta a lot of the times can cause problems. But what we have here is a different problem, right? What you have is almost like a horizontal escalation where you basically have user A, right, accessing user, all right, that didn't work. So you got user A accessing users B data. So what we now have here is this is normal user B, right? And basically you got a user accessing that user data, right? And that is actually much harder to defend if you don't do stuff in the back end, because the way you need to do in the back end is never ask the user who he is, right? So you always, from the back end, the pattern that you're looking for is you want to look at the session keys and the session identifiers, and you want to see the back end using that to determine who the user is. Because if that doesn't happen, it means that if I can trick the server side to think I have a different username, you are one little blind spot away from that occurring. So if you look here, all these requests at the moment are basically asking for the user to provide who it is.
But Dennis, you can view that as like a insecure direct object reference, right? Like instead of using a direct object, yeah, you can use a GUID or something. You don't use username as a primary key. But I think keeping user ID in a session means that you can't, it will be very difficult for microservice architecture. I don't know how feasible it is. Like if you have federated identity and you have to exchange you might have to extract the ID from a token or things like that, not necessarily from a URL parameter, but you can't always keep in the backend state, right? There are challenges.
Yeah, so these days, the one way to do it is to use this, right? So one way to do it is to use JSON Web Tokens, right? That basically give you, for example, that, right? And I really argue that here, I wouldn't even put this here, right? I would actually put a GUID here, right? I wouldn't even put this, right? But this, if this contains the user ID, right? So if this actually contain a GUID right here, right? Then what happens is that each of your microservices will be able to validate this.
Yeah.
Right. So that's
I don't
really nicely.
Yeah, that will scale. But I also won't recommend using JWT directly. Even like it should be a part of OIDC standard or something like that. I think many people are insecurely creating JWT. That will even make it more complicated, right? So.
And by the way, right, if you're using GWT, by default, the only thing you get is verification. You don't get
claim validation, and there are so many other things.
There's a lot of
JWT like our here be dragons.
On mute, Dennis. We can't hear you. I think you're on mute.
So there's a lot of cases where I've seen where the understanding is that the data is being encrypted because it looks like this, but actually this in JWT is literally this data is in clear text, right? It's just base 64. This is basically the signature which you do with your secret key, right?
Yeah.
You have to be careful with that.
And there are also situations like when they put JWT library, they accept non-algorithm. So anyone can generate a token without signature and it will get accepted. Right? So
yeah,
that is also common.
So guys, so any more, so can you see that in this case, right? One of the big things I would pick up when I'm looking at the code here, which you see that I kind of got my first notes by saying, hey, you know, how come when I log in again, I'm seeing somebody else use the data? And then the big thing there is a situation where actually you have the users, right? The username being provided here. And at this stage, so this is now a really good stage to look at the source code, right? And what you do here is, actually, let me open up the codes, you know, locally. So I was going to show you in GitHub, but actually, I'll show you on the code locally, right? So basically, sorry, just give me a second. Cool. I just need to open that file. And this is where I'll go a bit more, you know, strict on this, is that if you're doing any kind of security assessment, you have to look at the code, right? And but first of all, if you're doing a security assessment for somebody who doesn't give you the code, that's a finding already. But you know, you always should ask, right? And you always have to ask. And you guys should be able. Can you guys see my PyCharm?
No.
This is forensic.
Oh, it says forensic workbench. Sorry, my PyCharm is this application.
Yeah.
Right. So it's very important, right, that you you get the code and you have it locally. Ideally, you want to run it locally. So ideally, you want a situation where you can run the application locally, right, using the same environment as the developers. And actually, a sign of a nice, mature environment, right, is that you can run it locally, right? You know, you basically, what you want is literally to be able to run the website from your local host, right? So you want to be able to be in your local environment and actually see it going, because that will make you a lot more effective, right? So a good, you know, a sign of a good application is that when you go to them and saying, hey, you know, how can I run this locally? They basically go, cool, just run Docker Compose up, right? So if you just go, if you just, in this case, just go, hey, can you go and run Docker Compose up, right? So you see that command there? And that command, so I'm just going to run start dev servers, which we'll see in a second. And this is basically going to start run Docker Compose. So it's, I'll show you where it is. There you go, deploy Docker Compose up. And the first thing, that the reason this is important is because this is already a gold mine for you to understand how the application already works. And when I talk later about us visualizing and creating graphs dynamically from the source code, this is one of the things you should be parsing, right? And this could be the Kubernetes definition, the cubes and all that jazz, but this already tells you, right, every component that exists, every container that exists, every port that is open, and the relationship between the systems, right? And then, of course, once you got that, I can run the application locally, right? Which makes a big difference, right? And the thing about this now is that, you know, even if you don't understand the source code, right, and you never use it, you can just go like this, right? Like this. If I search for, look, for login your area, I just found the source code for that, right? Now, if it's really cool, you can just save it and it should refresh. There you go, right? See? So now I found out where in the source code things are, and And even if I don't understand, this framework or this thing, this allows me to actually being able to start to look at what's happening. And ideally, you probably want to even be in a position where you can put breakpoints, right, on here. And okay, go on. No, and you should be able to put a breakpoint in here. Oh, sorry, not this is the Java stuff. Although I thought I could put a breakpoint. All right. So you should be able to put a breakpoint, and then actually, start to look at things running. So because that again makes you more efficient. So and now what you can do is you can sit with the developer, right, and you can ask them to say, walk me through the application, right? So what you do is you follow the packet, right? So you start to understand how things work in the client, how things works in a server side. So you start to look at the data that gets created. So if I'm logging in here, I go, okay, so I'm handing my submission. There's my payload. So you get to see here, here's the payload being sent in basically, form posting and HTTP, forms. And actually, the first thing that you see, for example, is the password actually could have been encrypted on the client side. For example, just another defense in depth. But if you're using SSL, it's less problematic. But I've seen cases where you actually don't even send the password in clear text here, where you can see here that I'm going to take the username and password, and I can verify it on this side there. And I go, okay, so let's take a look. So if I go into the forensic workbench and put AAA here, right, and I submit it, you get to see the requests, and the requests at the bottom here, you get to see my username and password, right? So there you go, right? So there's that request, username A, password A, that's the value that goes in here. Now, once you've got that, you follow the packet on the server side. So the cool thing of this is you now have a very clear mental model. So the server-side code is here, and now you get to see, okay, where is the code? And look, there's nothing shameful of literally sitting down with the developer next to you and getting him to walk you through the structure, because they understand it more, they know how it works. So I can say, okay, walk me through how it works. So I got my app here. My app in this case is Express. Okay, it's going to start the server. And by the way, this code is going to be released under Apache and Creative Commons, right? So all this stuff is open source. So so basically now, okay, here's my server being set up, and now, oh, cool. So this is really interesting. Here's what I'm looking for. So here's my my routes being set up, right, on the application. Here's some security routes. Here's some error handling. Now, these lists is one of the first things that you want to find out in the backend, right? Because this list here should be, right, and actually, with some always exceptions, right, should be the full list of the attack surface on the server side. And that's one of the things that when you're doing a security review, you absolutely have to find out. You absolutely have to find out what is the attack surface, because again, if you remember, right, when I was talking about, hey, I want to make sure that no anonymous user or normal user can access the admin functionality, i.e. all the URLs. If you don't have the full list of URLs, there's no way to do that, right? So it's absolutely critical that you find, right, every single URL that exists. And sometimes this is not trivial to calculate. So for example, on some Spring apps or other apps that exist or other variations, sometimes it's really hard to actually calculate the exact URLs that exist on applications. I actually remember working once with some developers, and they had such a dynamic routing system in the back end that even they couldn't programmatically generate and figure out what URLs are actually possible because of the way, I think it was Go, the way the thing was actually set up. No, it was Go, it was the other Java one. I forgot the name, but it was Scala. So it was a Scala application because it's function programming and you can do some crazy stuff with it. All right, so now you get to see that this is the beginning of us following up. Now, if you have an IDE like this, I can go, well, clearly login. Look, can you see their login? So these are the URLs that are called by the front end, right? So in fact, I can come in here and go, oh, okay, you got view report, you got analysis get, sanitized files. So I should be able to come in here and say, look, there's view report. There is analysis get, going to be somewhere around here. And then view report is, there you go, analysis gets, right? So you can see that this is all the functionality in SView report that exists on the back end. And a lot of times blind spots occur because there's endpoints here that you might not think the user might hit that they might be able to hit. So now you get to see, okay, I got my login. I can go into my login page, and then I can go. Oh, I think I know the problem. I think my WebStorm, my PyCharm is actually misbehaving again, annoyingly. All right, so I need to go, and find it manually. That sucks. Right. So here's my login function. Right. So now this is the login function, right? That is called when you make the call, right? So now you can see that I'm going deeper, right, into actually what happens. So this calls the do login functionality, which is here, right, or down here, do login. There's my username and password, and then my find users, etc. And then now you start to see the sequence of events. And some of these sequence of events is important, right? Because there's a number of blind spots that can occur depending on this sequence of events. So I grab the username and password. I make sure that they exist. If not, username and password are provided. Then I go in here and I see find the user. If I find the user, I send a result back. Then I check if the user is active. And then if not, account suspended. Then I check the password, invalid login credentials. Now, there's an interesting case here. Can you guys spot two interesting vulnerabilities here?
Username enumeration.
Yeah. How would you do that?
Yeah, well, you try a username by checking the response error messages. You can identify if the user exists or not, if the passwords, the user exists and the password is invalid, etc.
Yeah. So this is another good example of if your security measure, if your security model depends on the username not being confidential, then leaking the username is a problem, right? But I remember an app that I created ages ago that we went to town because we really give no clue when the user logged in. If he was a bad user, account lockout, bad password, all sort of jazz, and it was a usability nightmare. Even us, the users, when we use the app as developers, drove us crazy, right? And it's a good example of actually a bad usability because you should not view the user as an asset. So although it's a vulnerability, this will be a case where you accept the risk that we leak and we allow username enumeration.
Yeah, the guys from WordPress actually have that mindset. They consider, not just WordPress or Facebook as well, but they consider username to be public information, so they don't care too much.
GitHub same as Twitter.
Right? Yeah. GitHub, right?
Twitter they do the same, and it will tell you if the user not found or suspended or something like that.
So from a security point of view, the trick here is to remove assets to protect. So in this case, we say, wait, the user is now not an asset, and then we accept as a developer team that risk, right? It doesn't mean that the risk is not there, but it means that we accept it. But of course, there's applications where maybe that's not acceptable, right? But it has to be, a knowledgeable thing, right? So now if I go and check my password, right? Now this gets interesting, right? Because here, one of the questions I have is, how do you handle your passwords, right? So, and this is where when you do your threat models and you follow up, for example, from a confidential point of view, it's very important that you handle the passwords correctly. So in this case, we're actually using Bcrypt, which is pretty cool. So that actually means that, the engine is actually using Bcrypt to compare, right? And then that's where I get the value if it works or not. So that means on the database, the password is actually encrypted using Bcrypt, which is a pretty good hashing algorithm. So you can see that I'm now going through this sort of motion of how they actually handle things. And in this case, it seems pretty all right. You know, I can enumerate users, but you know, I don't view them as assets. And then you know, I'm kind of okay with that. So now what you want to do is you want to log in, right, as the user that we want to take a look at, and continue, right? So okay, so now I'm logging in as the user, right? Oh, of course, sorry, I just realized this is my local. It doesn't have the user A. It has a user Q. So again, it's not it's not that bad, right? So okay, so now I got my data, and you can see like there is my request going through, and there is that file I was looking for, right? Localhost sanitized files, right? Which is basically is the same thing that I got here, right? So look, that server sanitized files. So this is a really powerful thing, right? It's very powerful to have a server that you can hit, and you can basically do black box testing, and you can fuzz, and you can destroy, can do whatever you want to it, because it should be your test environment. And the same thing running locally with the source codes, with your ability to investigate. And I would argue that without this, your efficiency as a pen tester or as a security researcher is very, very low. So, you know, always fight against it, right? And escalate if they're not given that access to. So we can now go back to our server and again, follow the rabbit hole, right? So I'm looking for sanitized files. So that guy should be somewhere around here. Again, you know, just do a search if you want, right? There you go. So there's my, so you, and already immediately, look, I can already see the pattern, right? So if you're looking at finding, you know, vulnerabilities, look, here's them by the bucket load, right? Username, user ID, every one of these is a vulnerability. Because, you know, in a way, actually, probably these are less, assuming that the user ID is actually decent, because this is our admin, sorry. But these ones are a problem. This one's here, right? See that one, that one, that one, that one, that one, that one. Every one of these is now forcing the downloads, the function to check, does this user has access to that data? And he should do that check, but he should never get the value of who the user is from here. Especially if it's, you know, for their own material. So if I go into the sanitized files, see here, you go db get files. So let's look into that function, right? Which is here. And now what we're now getting is we're starting to get a mental model for how the application actually works. And now the other thing that I would absolutely call as a problem is this line. What's wrong with this line from a validation and a sanitization point of view?
Don't do inputs, validation.
Sorry?
So you are passing direct input from the URL to the user attribute, right? The constant.
Yeah. So you see, right, that at the moment I'm taking the data from here. So this is the first place where data enters the application, right? This is request, which will come, the parameters is there. The username is actually the value that gets provided here, right? So in fact, that username for reference is mapped from here. So if I change that to AAA, then that value should be username AAA, right? And this is now, so there's no validation here. And the biggest problem I have with this pattern is that when you hear, you kind of can see and understand that this is untrusted data, right? So at this moment in time, right, you could see that username, right? Actually, I think I'm actually on, right? I'm on the server side, right? So let me go back to the, oh, sorry, I'm on server side, yes, sorry. I got confused, I thought it was a Python app. All right, cool. So I'm on the server side. So this username here is untrusted, right? Now, the big problem here is, so that means that this user value. So this is, when you do static analysis, this is called, this value is now tainted, right? So we can't trust this. So basically this should be untrusted, right? Because we don't trust this value, right? But the problem here is that you're taking this and you're putting it here. And the biggest problem now is that when you go into GW actions and you look inside of it, what you now basically start to lose is this understanding that that value here is now tainted. So this value is now malicious, which is so is that, and so is that. So that means that every place, right, that that value is used, potentially is now a vulnerability. And the other thing that's important is that if I look at my user, right, the user requirements for it are actually quite strict. So there's actually a really cool function here, which basically takes, there you go, right? So there's actually a really cool other part of the app that takes this regex and validates that and throws an error if not possible, right? And this is basically a regex that only allows space, lowercase things, right? And the scores, etc. But the problem is, at the moment, and this is a very important pattern to always look in the source code, is that, and every application you look, is how deep this bad data gets into. Because this user file here, this user value is untrusted, and the reality is that this is actually a string, right? And the string might not look so benign, bad for you, but the problem with strings is that, you know, if you look in JavaScript, right, a string is potentially in JavaScript is a maximum 1 gigabyte of data, right? Well, maybe the app won't allow you to send you that, but this is definitely not, right, what I expect it to be. So this could be a massive set of data that I'm now allowing to enter my system. So, and now can you guys spot another vulnerability here? Because I don't trust this data because it comes directly from the outside world.
It could be a command injection, but we need to see the file analyze at the bottom.
Could be, but there's one that you should be able to see, one type of injection that is kind of here.
Path traversal?
Sorry?
Yeah.
Path traversal?
Yeah.
Yeah.
Here.
Yeah.
Now, the interesting thing of this, right, is that there's, and this is now very, very, so there's some server-side implementations where this is just about safe if the URL comes from here, right? And because if you do this, your browser, the request would actually be translated to that. The problem is there were some versions of nodes, right? In the past, I remember writing some exploits where I would basically do this. And 2F is the, basically is the backslash, right? So what this allowed me to do is this is the equivalent of going back a directory. And it would, but the thing would actually pick this, sorry, a percentage, sorry, 2F. So it would pick this, which is basically that value. And remember, percentage 2F is the backslash, right? So the payload we then here, so the value that would arrive in here is actually that. And if that's the value that arrives in here, then you have, like you guys say, you have path transversal. So basically you'll be able to, in this case, save files outside the data root. And this is kind of a very big problem in a lot of apps because, you know, you take all these strings from the web services, and then you have to realize that every single string that you take, in fact, every single field, you have to validate it at the gate. right? So basically your first layer of defense has to be here, where every single field that is basically inserted in the application and everything that you get from places like this, request.body, right? Things like this, words, username. See, every one of these guys, you know, GUID is actually a good idea, right? Because then you should actually be able to validate it, right? And there's a couple of places where that already happens, right? Every one of these places, you have to validate the data as soon as he enters your system. Because if you don't, right, you risk basically situations where your downstream methods might not be aware that that data is now entrusted. Does that make sense? Cool. And so in this case, if you look at the problem here, the problem is if you look at that sanitized files and the way it's done, it means that in the server side, the user folder is actually, you know, depending on the username. And this is where, again, if you have access to the information, you go back to the server side and you go back to, you know, what's going on in the server, and you list what's happening, and there's our FW data, right? And there's all the users, right? See? So here are all the users that currently exist in this application, right? And each of these has a folder. Now, this is actually quite cool because when you look in here, each of these folders basically contains the analysis that you're going to be able to see from the front end. So what you're actually seeing here is almost a database, which is file-based sort of structured, which is actually a pretty cool way of doing it. I quite like it. But the blind spot here is the fact that you use that username in the beginning, right, to determine your path. In fact, the biggest blind spot is that if you look at the request that is made, the blind spot is that if you look at the actual, you know, there's another problem here, which is the authorization token. So if you look at the authorization token, this second part is good, the first part is not. So if you look at the authorization token, which is sent with every request, which is good, right? On the request, there should be authorization token there. What actually is happening is you basically getting, and I'll show you with the other user, right? Is you basically sending the username and the token. So ideally, you should just send this, because this should be enough for the server side to determine the name, and more importantly, to allocate on the server side that value as the username. So you should never ask the user who he is. And this is a very powerful pattern. And I found tons of vulnerabilities simply by following IDs that should never be placed in the client side. You know, which, as Dinis mentioned, this is called indirect object references, which is basically when you actually use a direct reference on the client side to something that means something on the server side.
I think then it is insecure direct object reference.
Sorry?
It's an insecure direct object reference.
Yeah, sorry, insecure direct reference. Yes, because you're using a direct reference. Yes. The vulnerability is insecure direct references. Yeah, correct. So, and this is basically a vulnerability that if you look at it, right, the interesting that you can see here is that, first of all, if you try to access the thing directly, there's some missing credentials, right? And Petra, for the ones that you guys were looking at the previous version of this app, this wasn't there, for example, right? So in the previous version of the app, the first alpha, actually this was not even there. Now, the question that you want to ask is why? Who did this? Because, and this is very important, because what you now need to do is you need to reverse engineer the authorization model from the server side, right? And this is super critical. So what you want to do now is you want to go to the server code and again, sit down with the developer, get them to answer that question, because they should know, right? And if they don't, that's even more worrying, right? So where does it happen? And in this case, it's here. So if you look at this, there's a security route that is added, who is actually going to call this security API. And the security API is going to call the authenticate requests. So let's take a look at that. And the authenticate request. So what you're looking now is for lots of patterns that are important, right? And this is basically where you want to see, right? For example, and actually it's interesting because I should actually share the code because the previous version of this actually did it wrongly. So one of the first things you want to look here is that, is the model open or closed, right? So are you failing open or are you failing closed? So that means that, for example, if you fail open, means that you try to do all your security checks, and if none of them have a problem, right, you let it go. And what you want is almost the other way around, where you will, if you need to authenticate, right, in this particular case, the last one should always be unauthorized. So let's look at this, right? So now, so what we're trying to figure out here is, how is the decision made? Can a user A access stuff from user B? So if you look at now these methods, this method is actually, you know, should be here. There you go, sorry. So what this method is basically looking at in this case is he's saying, okay, take the segments that you get, right? You know, take the routes, anonymous routes, and this is interesting because you go, oh, okay, how does it work? Oh, okay, cool. So I got a list here of my anonymous routes, right? So what you now get, so now what we're looking at on a plate is the authorization model on the server side. And this is very important because you now want to write security tests that check for this. So, and what you also get from a pen testing point of view, security review, you're getting a list of everything that is expected to be called, right, from anonymous users. So we now need to review all of those and make sure that none of them contain information that should be actually not available publicly. And then you can see next, you get all the user routes, which are here, and you get all the admin routes, which are there. So in this case, these are the routes that only your admin should be able to access. This is the routes that only your users should be able to access. And these are the ones that everybody should be able to access it. And this, you know, mapping here, where you take all your URLs and the authorization model, is super critical for you to now add tests and then basically confirm that the UI expectation, i.e. the expectation for the user, you know, or management or et cetera, is actually correct. And in this case, you get to see that if, for example, a normal user tries to edit a user or create a new user, is not going to be able to, basically is not possible, right? In fact, there's actually, it's interesting because one of the things that is missing here, which I actually would argue that should also be done. So I will actually add is basically, sorry, let me rephrase this. These are all the ones that the admins can do, and this is the ones that the super admins can do, right? Sorry, like correctly. So this is actually nicely done because it means that we're assuming that anything else at the moment that is not here, right? Every route that is currently possible that is not listed here can only be accessed by the super admins. That's cool, yes. Because in the past, we actually had this thing here, right? And it's not. So now you can see that the user can create, the admin user can create new users, but this one can't. So we want to double check this, but this you know, in a way is giving you that mapping to say, you know, these are the stuff that we want users and admins to be able to do, and this is the one that we want users to be able to do. And what this is preventing is that elevation of privilege from one layer to the other. And the challenge now on this app, and where there's a number of issues that we need to address, and again, this is beta, right? So this app at the moment is not designed for a secure multi-user environment, right? Is that there's not protection between users. So that means that once you can upload a file, once you can download a file, once you can delete a file, you can do that for every single user in the system. Any questions with that? Or comments? So is that a good or a bad problem? Is that acceptable? Or how could you make that acceptable? Any ideas? So my point here, right, is that, and this is now from a risk point of view, right? So what we determine, right, and so we follow that rabbit hole. So we determine that now, you know, not only I can access, so the point here is if you now change this, so if you intercept this traffic to modify using Fiddler or Zap or something else, right? And you call this request with another username there, you will be able to get a response with their data, right? So you get their data, right? So you can see that now the problem that we have here is that there isn't on this app isolation between these users. So how do you now address this from a kind of a risk mitigation point of view?
I mean, you should sorry. Can you go back, Dennis? I missed last 5 minutes. Can you go back which functionality you are referring?
Yeah. So what I'm saying is that if you look, so these are the routes that are available to anonymous, to users, to admins. Everything else is a super admin. So what you can see in this application, there's a good layer of security between multiple types of users, right? So you whitelisting what the user can do, and you whitelisting what the admin can do, and yeah, you want to look at some of these to make sure there is no major blind spots, especially something like this that should only be done here. But the application has a good layer there. The problem is that, as you can see, we pass when we basically go in here and grab the user files, right? And we basically grab the sanitized files from the server, right? What you see is that, you know, and we already look at the code. Oh, somebody modify that. Basically, what you get is where is it? There you go. So see that list there, which is a list of files that you see here, is basically determined by that value there, which is the username. So if I modify that value, right, because I'm authorized to call sanitized files, I can change this to any other user.
Yeah. So there is no ownership of the file to a user. That user is allowed to download.
Yes. So I user Q can access data from user admin, or user Dinis, or user do not delete, or user Luke, etc.
So there is no proper authorization model around the file objects here.
No, correct. So now that's a risk that we have to accept, right? And this is why it's so important from a workflow point of view that you map all your risks and vulnerabilities during development, because it's very important to understand what is the line that you should cross to say this is now ready to go live, or to determine what type of use cases your application is usable for. So every application in my book has vulnerabilities and risks. The question is are those risks acceptable for the use case that you have at hand? So here, this application is vulnerable to authorization bypass from user to user, right? So So the question I have is, how can you now address this from a kind of a risk point of view, so that you can deploy this product to customers, or you can get customers to use this? Because I can argue that from a usability point of view, this is already, already there's a lot of good stuff. The files get cleaned, file gets rebuilt. You can tag images, you can tag files, you can see, you can basically look at the functionality of the file, you can basically access it. So I would argue that from a usability point of view, this is already pretty cool, right? The problem is that it has those vulnerabilities, right? So, nicely functional. I can come in here, I can edit the tags, I can get more files, like from a security point of view, it's already a cool product. The question is, how can we use this securely? So how can I ship this to a customer, in a way that the fact that this user can access that data, right? It's not a problem. Oh, that's why I do.
Kind of let them know that all the files are going to be public available in a way that don't upload sensitive information. If they do, it should be fine.
Yeah, I like where you're going. Yes. So what you're doing, right, is you're now changing almost the rules of the game, right?
Yeah.
So you're basically saying, look, so if this is why, and I cannot stress this important enough, right? If you map every vulnerability and every risk that the application has, you actually are making life much easier for every party involved, because everybody can now make good decisions. So it's very easy to look at the product like this, right? And this is what happens in the real world. You look at a product like this and you're going, cool, I can add users and I can delete users. This thing kind of feels fine, feels powerful, right? Then, surely now the files are isolated between A and B, right? And in security, we should know that's never the case, right? We should know that actually until you verify it, you should always, assume that sometimes that's not possible. So in this case, I like that solution, and that's kind of where I was going, which is the idea that if we tell the customer that this is now their environment, and this is where now it's important, because if you look at the way this is set up, right? And I'm just going to grab my favorite. I just need to log in quickly here, sorry, into using my single sign-on AWS environment. So I can basically show you that. Cool, right? So we're back in. So if I now show you that what you're seeing there is basically this EC2 instance that I got here, right? And literally I can come in here and I can start a new one, right? And let's say micro, right? And actually I can do this programmatically, but I can also do it from here, and I pick the right firewall group, right? So I can now start a new instance, and you can see that I can now turn around and ask the same question from the point of view of this EC2 instance, right? So if I give this EC2 instance to a customer and say, this is for customer X, right? And they have full access to this. I can even give them SSH access if they want to, right? And this is dedicated to them. All the files, for example, the files I was showing you there. So when I'm here, right, I'm literally inside that environment, right? So this system here that you see there, that is that environment there, right? So if I now turn around to the customer and saying, here's an environment for you, you own it, you have access to it, you got multiple users, but you need to understand that one user might be able to see the other users, but actually from a usability point of view, it's quite nice to be able to segment them and only have the users, the files that you uploaded in each account. Is that then a problem?
I mean, I don't think it is. I mean, if the user is aware, I think it should be fine.
Yeah.
Well,
and now look, and that's a massive principle in security, right? So if you look at the meta principles that I follow when I do security analysis or thinking, I follow the packets the way you guys saw here, right? But I also try to apply this, security minimization model where you try to reduce the number of assets and the number of things that you have to protect. And a lot of this is about redefining the problem, right? So sometimes the best way to find a solution is to actually redefine the problem that you're addressing. So if I turn around and say that this application, the domain model of the application and the security boundary of the application is actually the EC2 instance, right? Then the security vulnerabilities, the risks that are real that I have to accept, right, are actually now much lower. They're very different if it was the other around. So you can see here that at the moment I can spin up these new instances like very easily. And in fact, the idea is to actually also run this in Kubernetes clusters, but you can see that I can now make the EC2 instance the security boundary of the application. And if that's the case, then that vulnerability, the risk is really low. So you get to see that the same vulnerability, a user A is able to access user B data, right? If the boundary is the actual environment, then that vulnerability, although still exists, the risk is really low. Where if I put this available on the internet, or if the expectation of the client is that user A is not supposed to see AAA's data, and only admins or super admins are supposed to see it, then the risk is high. Does that make sense?
It makes sense. It's always a tricky one because if you have users and if each user is supposed to upload files, it's kind of expected for their files to be visible by themselves only, or for someone that has higher access, not someone with exactly the same level of access. Although you can, as you mentioned, you can change the rules of the game, but at the same time, not every user should have SSH access, and not every user should see the files of user with the same level of access. Otherwise, why do you need accounts per user under the?
Well, I tell you, so on this application, and this is important, right? So I would say on this application, the user accounts are a usability feature. They're not a security feature.
Kind of just like to allow people to upload files and you can map the files to the users.
Yeah, like
just to filter or something.
Correct.
Right. Fair enough. Fair enough. Yeah.
So if I come in here and I go, if I log in, right, and and I basically take a look at, some of the users, right, and they have tons of files, right, then it's actually, I can come in here and I can upload piles of files. But actually, when I was doing some of my analysis, right, I actually sometimes wanted to have only 5 or 10 files. I don't want, and there's all the tasks where you upload hundreds or thousands of files, right? Because you want to do some kind of analysis or some cleanup files or some processing. And so in this case, the user kind of experience is a usability feature, right? The user feature, sorry, is a usability feature, not a security feature.
Dennis, you can also implement that using tags and filters. You don't have to necessarily complicate many user account groups and all this kind of stuff, right? If you want to have a simplified interface, this kind of give a misunderstanding to the end user that they are getting some kind of security from authenticating, but actually they are not getting the security, right? So
yeah, but even on this case, right? Like, a lot of the UI is based on all the files, right? So if you think about it, a lot of the UI here is based on processing all the files that this user gets to see. So if I'm, for example, doing a new analysis, I actually like the fact that I can come in there and create a new view. Now, you're right. This can be implemented as different views. And that's now actually, you move the conversation to the correct place. Now it becomes a usability king. Is it better to create multiple views? Is it better to create multiple users? The important is to redefine where the security boundary is. And in lots of applications, the understanding of the security boundary is not very well defined, right? Which is kind of my point in this, that sometimes the way you protect an application, or the way you make sure that, for example, this application is not put at harm's way, is not to put this application in a place where you need to have multiple users, right? Like without isolation. And then I would argue that if that's what you want, then we would spin up a new EC2 instance for you.
Yeah, I got your point. I was just saying, like, user authentication itself is a security feature, but I mean, if it is not need to highlight as a security, I mean, there shouldn't be more user accounts. That's my view, but I got your view that you know, you can, yeah, check.
Yeah, and this is what I feel like in security, right? It's very important. Like, I always go back to the point now, you know, we only have a certain amount of credits in the next sprint, right? Or points in the next sprint or the next development for the dev team to implement security features. Let's make sure that they focus on the right ones, right? So if we, for example, on this application, if we can say that for now, the EC2 instance is the security boundary, you know, you can create one EC2 instance per user. So again, you just get one login, right? Or you can create one that they can create multiple user accounts from a usability point of view. Then, you know, what it does, it means that, okay, so we don't need to spend our security credits on that. Let's see what other things from a security point of view we want to fix, right? And that's, you know, so we now might want to fix, for example, you know, some issues related to, if I send a huge amount of files, what happens? Where are the limits on the server? What is the point where the server starts to struggle, right? So that might be more problematic, because then the application stops working, right? So this is where, so what's interesting, for example, about this application is now very sensitive to the environment that you run in them. Because the reality is that if you run this actually with a micro, like, you know, with basically with a T1 micro, then the amount of scans and the amount of analysis you can do is very different if you run with a large or with an Excel large, right? So from a security point of view, I'm actually more worried about the UI stops working if you actually send a lot of files. And if you actually you can probably deny those servers the whole thing, because what happens when things run out of memory is they don't fail gracefully. So now becomes a question of, from, you know, where do you want to invest your security credits, and where you should get the team to focus on in implementing these solutions.
Yeah, it's an interesting question, right? So, is if you consider confidentiality or availability, which one is more important? Like, it also depends upon who is going to use the application and what kind of files they will be uploading, right? So, yeah.
Well, so this application is designed for you to send malicious files. Literally,
Okay,
that's the point, right?
Okay,
the point of this is that you upload your files that have macros and malicious stuff, right? You know, you basically send files that have, you know, JavaScript and macros and other crap on it, right? And then the point is to, you know, get a clean file on the other end, right? So literally, this is designed, so you can see here, right? So if I take that macros XLS, which got uploaded here, right? And it has, you know, macros. The point of this application is to download the file. So if I now do a round trip of it, you get to see that this new file now doesn't have anything, right? So new file is completely clean, right? See? So this is an application designed to upload malicious files. And if you, for example, a security researcher doing reviews or actually even handling an incident, this is already super valuable, right? So the key here from a security angle is to now, you know, understand where do we need to spend the time in our analysis. And what's interesting from a pattern point of view if you compare this with the file drop, which is basically the Lambda version of that, one of the things I'm worried with here is the fact that because Lambdas get reused, if somebody finds a way to pop our engine and stay in memory, the next time the Lambda executes, the payload is still going to be there. Where this version is actually using Docker, so it's basically spinning up a new Docker image, new Docker container per file process, which is a lot more secure. So one of the efforts, one of the design goals for this app was actually not to use Lambda, not to use not to use in-memory process, because there's one version we can do it because we got shims for it, is to actually use one Docker container per file, per upload, which gives us the ability to say, even if something really bad happens during that upload, the next file that you process is completely clean, which is a pretty cool pattern from a security point of view. Cool. So that's kind of, the stuff that I wanted to guys walk you through. Please, so you can actually access the server there, right? You could also, there's also a version of this on here. So you can go to forensicworkbench.com. There's a public version there, and basically have a go, right? And I'm actually going to publish the source code later this week, right? Because the only reason I didn't publish the main repo now is because the repo that we have actually has the full version of the engine, and I just need to put in one that has a Docker image that has the evaluation version, which basically means he only lasts for a couple of weeks. But then, have a go, find some vulnerabilities. This is a nice real-world app. You can, try to exploit it, try to see if you find blind spots on it. And if you do, let us know. And I think we're going to start a bug bounty system too, a bug bounty kind of thing, and hack away, right? But also throw some malware to this, right? Because the other thing they might want to try to figure out is, can you actually crash the engine, right? Can you bypass our engine? Can you basically send a file here that has macros or JavaScript or really bad stuff or all sorts of insane things, right? And can you actually bypass it?
On it.
Sorry, go on.
No, sorry, I'm just saying we are on it now.
Yeah. So the other thing that you might want to play with, if you want, is you can actually export these files, and so you can actually take a look at what happens inside some of these files. So we actually expose the intermediate representation of the content of those files. So you see here, right? So you see that PowerPoint there, right? That you had. This is actually the intermediate representation. This is a version of, this is SYSL, which is something that is used by some agencies, but we can also export an XML. But this is actually the images that exist inside that PowerPoint, right? So we can actually take this zip file and we can recreate the file, again. In fact, one of the insane patterns that we have is that you can literally take these files and you can send it over the network in that intermediate representation, and then we can rebuild it in the other side. So that actually means that theoretically you could print this, send it over the post, and actually scan it on the other hand, and you get the file rebuilt, which is kind of what the real secure environments do, which is, okay, it's not printed, but they have what's called a diodes, which basically takes the original file, exports it into the intermediate representations of the files, and then actually rebuild it on the other side. And this is really cool because, sorry, go on.
I was just saying, one of the other things that's really nice with the export import, we did this and we demonstrated it to one of our clients, was that you could actually, certainly with the images, that you can actually replace the images within those files with something completely different.
Yeah, so you can start to edit. And actually, in some of these, you could also modify the content, right? So you could also see the content of the files when you export, and you can actually see the contents in clear text, right?
Yeah.
Which is pretty cool. And if you look at some of these guys here, for example, I was actually looking just early now. If you look at the VS Code, if you look at so this is, for example, an XML file export of actually the XLS. So you see, so this is kind of how it looks like, and this is the XML export of a binary file. So now you get to see that if you want to do analysis on binary files or WAV files or all sorts of other files that we already support, we give you the XML file of the actual structure of actually what's happening inside that file. And of course, some parts of it are binary. So in this case, this is a binary SO file. So some parts of it will actually be the shell code, but it's actually really cool to already be able to have access to all the other bits. So for example, when I was looking at the WAV file, you can actually use this to see the metadata and to see the structure and how many blocks exist and all that jazz, which is kind of how the engine works, right? So the engine is going to look at this and make sure that these fields and this stuff is all correct, and these sizes are all correct, etc. So yeah, so it's pretty cool to play around with. I think there's a huge amount of very cool research you can do on this. And Petra, I don't think she's in now, but she's doing some really cool research on actually using this for machine learning, and which is a really cool research topic. And basically, let's see if I can find it. And basically, what she, I need to find. Where's the thing? So it has some really cool engineering stuff that you can do with this. See, Greg, this is why we need to get all our stuff in one place, man, so I can find it easily, right? I think I can find it. It's over here. Yeah, so there's some really cool research that you can do on top of this thing, because what you get like a three-dimensional view of the files, which is here we go, found it. I think is this. No, it's not that. Sorry. All right, I'll see if I can get the link, and then all right, can't easily find it. So right, cool. So any final questions or stuff you guys want to mention? Okay, found it. There you go, man. I always use Twitter to find stuff. There you go. Yeah, so this is basically the research that she published, and what she did was she took the data and notebooks, and the idea is that can you determine if you feed malicious files to an engine where you extract all the IDs and all the stuff that we determined from the file, so the export of the things we discover on the file, and then you feed good files, right? Are you able to then determine when you feed the next file if it's malicious or not? So it's pretty cool, right? So she's done some analysis, she does some stuff around this, and the logic here is that you want this number recall to be quite high. So this is kind of like the index that she discovered, and then she tried different versions. So you can see the precision here is higher than there. The bottom line is that when you use multiple algorithms, we will find that this particular one here, the RFC, I think rainforest or something like that thingy, is actually a lot more efficient than these others. So this is a really cool example. So where we have here the situation there, once we teach the engine, if we feed a new file that we never seen before, can we determine if it's malicious based on the metadata that we extracted and the file structure that we sent? So yes, if you want to do some machine learning research, again, this is really cool, right? And all the stuff that we do in this case is open, right? So please come along, participate, and join the effort. So cool. I think that's kind of it. I was going to show you. Hack away, find vulnerabilities, let us know what you think, blow up the engine, right? and you can find us if you find anything interesting.
Thanks, Dinis.
Cool. Let me just stop the recording.